Hello again, everyone. Mr. Reeves back with you today, and we're going to be looking at simplifying powers. We're going to step it up a little bit today in that we are going to continue what we've been doing, but we're going to add a few things. One, we're going to be adding coefficients. Two, we're going to be mixing up the operations, not just doing one at a time, but doing sometimes several at the same time. Okay. So if you go back to the very first video that I ever did on exponents and powers, I believe I wrote something like this: a times x to the n. And I said that this whole thing was called a power. And I said that the a right here was called the coefficient. And the x was called the base. And the n is called the exponent, or sometimes we refer to it as the power, which I have said several times can be confusing because the entire thing is called a power, and also just the exponent at times is called the power. So when someone talks about a power, you have to listen to the context to see, are they talking about the entire expression or just the exponent? But we have been doing all of our problems without coefficients. The coefficients have not been there. All right, but now we're going to go ahead and put those coefficients on there. All right, so we are going to have coefficients in the problem. So that's one thing I need to talk to you about today, is how to work with the coefficients. It's really not that complicated. And then we're going to be looking at some different examples of problems where we have not just one operation, but more than one operation. Okay. All right, so let's go ahead now and let's just dive in with these problems. Now, I've separated this worksheet by the type of problem. All right, so first one, multiplication problems. You will see on all of these problems, I have a dot, which means it is a multiplication problem, right? So let's talk first about the coefficients, okay? So coefficient would be the number out front. If a coefficient is not written, just like an exponent, if it's not written, it's a 1. So sometimes you might find it helpful. Let's see, are there any more on here? Doesn't look like it. Oh, right here, that have a coefficient of 1. Okay, now if you simply ignore the power part of these problems, then you will know what to do with the coefficients. If I took this away and I took this away, and I simply asked you, what is 1 times 10? I hope you all would tell me 10, right? Well, coefficients work independently of what comes after them. So right here, I have 10 times 4. So what's the answer going to be? It's going to be 40, and so on. Okay? So what do we do in these problems? We multiply the coefficients. That should surprise no one. Okay? We're going to multiply the coefficients in a multiplication problem. So this one's 8 times 10, this one's 2 times 6, this one's 8 times 2, this one is 7 times 4 times 8, okay? So we're going to multiply the coefficients, which wouldn't be a problem except we do something different with the exponents, right? Do you remember in these problems? We add the exponents, right? We add the exponents. So let me go ahead and go to let's do this problem right here. Okay, so I would do 7 times 4 times 8, and I would get whatever that answer is. Okay, and then I would have to do x to the 6th times x to the 10th times x to the 8th. So that's going to be x to the 6 plus 10 is 16. 16 plus 8 is 24, right? And then I've got y. I've got y to the 7th times y to the 4th. And by the way, if there isn't a y, it would be y to the 0 power because that's 1, right? 7 plus 4 is 11 plus 0 is 11. Or if that confuses you, if there's nothing else in the other term, you just work with what you have, okay? And then again, this part here would be 28 times 8. Why don't I go ahead and do that? 8 times 8 is 64. Carry the 6. 8 times 2 is 16. 16 plus 6 is 22. So the answer to this one would be 224. X to the 24th, y to the 11th. So again, we're going to multiply the coefficients. We're going to add the exponents. Where students get confused is it's one problem and we're doing two different things. But coefficients never do the same thing as the exponents. Did you hear what I just said? Let me say that again. Coefficients never do the same thing as the exponents. We multiply the coefficients, we add the exponents. If you're multiplying on both or adding on both, you're guaranteed to get it wrong. Okay, so that's how we do the first part, multiplying powers. All right, let's go on now to, I'm actually going to go down to the division problems because I'm going to do them in the order that we did them. So I'm going to do division next, okay? All right, I bet you know what we're going to do with the coefficients in a division problem. All right, we are going to divide the coefficients, but I'm going to add something here. I'm going to put divide or simplify the coefficients because we want our answer to be a fraction and not a mixed number or a decimal. Sometimes if it doesn't divide evenly, and I'll be honest with you, more often than not, it's not going to divide evenly. You're going to simplify. And then what are we going to do with the exponents? What do we do in a division problem? We subtract the exponents. Okay, but remember, no negative exponents allowed. So what do we have to do? We have to move as needed. Okay, move as needed. So remember, a negative exponent on the bottom becomes a positive exponent on the top, and a negative exponent on the top becomes a positive exponent on the bottom. I'm going to show you a little trick that makes it so you don't have to move it at the end. You get an answer and move it. All right, so let's look at one of these problems. And I'm looking, and I was hoping I'd have one that went in evenly. All right, so here we go. So I'm going to skip down here to number 27. All right, and the reason I'm skipping down to 27 is the only one I see here. Oh, this one as well if I divide that direction, okay? Negative 27 divided by negative 3. Again, if I crossed all of this off and I just asked you, what is a negative 27 divided by a negative 3? I hope you would tell me it's a positive 9, right? Does that make sense? So coefficients, you can ignore everything else and just do what is there. All right, on this one, if I crossed everything out, if I said you have a fraction here, negative 4 over negative 12, can you simplify that fraction for me? Well, let's see. I could divide both of these by negative 4 correctly. Correct, I mean. And what would I get? I would get 1 over 3. Okay? And then sometimes what's going to happen is you can't do anything at all with the coefficients. For example, right here I have 22 and 19. All right. The only common factor those two have is 1. So I simply would write 22 over 19. So divide or simplify the coefficients. And I'm going to write here if possible, because sometimes, like in this case, you won't be able to. All right. So simplify this one. You could divide them both by 2. This one you could divide them both by 5, right? This one you could divide them both by 2. So simplify. Hopefully you all remember how to do that. Divide if you can. Then we're going to subtract the exponents. We're going to subtract the exponents. But keep in mind, sometimes we might get a negative exponent. Now, in this case, we wouldn't, right? 22 minus 15 is what? 7. And 20 minus 16 is 4. So that's the answer that I would go ahead and get for that one. But what if I have more on the bottom, right? Okay, so in this case, again, I'm going to let you do the coefficient part. But right here, if I did 4 minus 11, I would get x to the negative 7. And if I did 25 minus 26, I would get y to the negative 1, right? But since we're not allowed to have negative exponents, I would then have to move that one down to the bottom, and I would have to move that one down to the bottom. And again, I didn't do the coefficient part. That part you're going to need to do. Okay, there is something you could do. If you want to avoid this negative exponent issue, there is a way around it. And the way around it is you're still going to subtract, but you simply, if you have a bigger number on the bottom, you subtract up instead of down. For example, right here with the y's, if I did 5 minus 8, that's going to give me y to the negative 3, right? But if I do 8 minus, whoa, what just happened? But if I do 8 minus 5, I'm going to get positive 3. So I simply say, where do I have more? Since I have more on the bottom, I'm going to subtract up. 8 minus 5 is 3, but I need to remember to keep my answer on the bottom, right? Where do I have more and how many more do I have? In this case, I have more b's on the bottom, so I could subtract up, but then I need to remember to put my answer on the bottom, all right? So in this case, again, I have 27 b's on the bottom and 9 b's on the top. That's going to give me 27 minus 18 is 27 minus 9 is 18, and I put that answer on the bottom. If I had subtracted, I would have gotten b to the negative 18 on the top, and then I would have had to move it down. So we're just simply saving a step. You don't have to do that. You can always subtract going down and then move them if you need to, or simply ask yourself, where do I have more of that variable, and how many more do I have? If you have a bigger exponent on the top, subtract down and keep your answer on the top. If you have a bigger exponent on the bottom, subtract up and keep that answer on the bottom. And by the way, if there's nothing there, like this is x to the 8th on the bottom and there's no x's on the top, then you simply write, this one simply would have an x to the 8 on the bottom. Okay? All right, so that's how you do the division problems. Now let's go to raising to a power. Once again, we have our coefficients, right? And what are we going to do? We're going to raise the coefficient. We're going to raise the coefficient to the power. All right, have you noticed the coefficients just do whatever the problem says to do? All right, when we had a multiplication problem, we multiplied the coefficients, right? When we had a division problem, we divided the coefficients. Now we have a raising to a power problem. We're going to raise the coefficients to a power. So right here, here's my coefficient 4, here's my power 2. Here's my coefficient 2, here's my power 3. Here's my coefficient negative 3, here's my power 4. Here's my coefficient negative 3, here's my power 4. So I'm going to have 4 to the second power. I'm going to have 2 to the third power. Does that make sense? I'm going to have negative 3 to the fourth power. Now, we know what 4 squared is, don't we? So it's going to be 16. We know what 2/3 is. 2 to the third power, it's going to be 8. And negative 3 to the fourth power, I believe, is going to be 81, right? But then what do we do with the exponents? Remember what we do? We multiply the exponents, okay? We multiply the exponents. So in this case, I'm going to have u, remember if there's no exponent written there, it's 1, u to the second power because 1 times 2 is 2, and then I'm going to have v to the 8th power because 4 times 2 is 8. On this one, I'm going to have a, again, this is a 1. 1 times 3 is 3, and b to the 2 times 3 is 6, right? On this one, I'm going to have x to the 4th power, and then I'm going to have y to the 8th power. All right? Okay, and by the way, in cases like this where you have 2 of them, remember order of operations, okay? If we have PEMDAS, which we do, order of operations, you do what's inside the parentheses first. Now, again, these parentheses here are separating the powers, so you're not doing anything inside these parentheses. Then you do exponents, which in this case is powers before multiplication. So raise this to a power, raise this to a power, and then multiply. So do this, and then multiply. All right, raising to a power comes before multiplication. So let me write that down. Raise to the power before multiplying. Okay. So on problems like this one, and this one, where there's powers, do the power part first. So again, this one right here would be -3 squared n to the 4th times -2 squared n to the 4th. And then we could simplify this to 9n to the 4th times 4n to the 4th. And then finally, we could simplify 9 times 4 would be 36. And then n to the 4th times n to the 4th would be n to the 8th. Okay, so that's what I'm talking about in those type of problems. All right, so we had multiplication problems at the top. We did quotient problems. We did raising to a power. And then finally, we have just a mixture of different types of problems together. All right, this isn't anything new necessarily. They're just kind of mixed up with you needing to remember, again, always remember order of operations always applies. Okay, order of operations always applies. Remember, anything to the 0 power except 0 is 1. So that part right in there would become -1 to the 4th power. This one right here would become -1. That part right there. Okay. This is a case, by the way, this is a case where you would do what's inside the parentheses first and then raise to that power. This is a case of where you actually can do something inside the parentheses. Remember, when you have a negative, if it helps you out, you could put a 1 there. Those count as coefficients of -1. All right, so if it helps you out, you always want a coefficient. If there's no coefficient there, it's a 1. You could put 1s on all of these, and maybe that will make it a little less confusing for you. All right, and remember again, a negative exponent, a to the -3, is 1 over a to the +3. So if you have a negative exponent on the top, you move it down. Okay, in a case like this, you're going to get, well, if we did the first part, right, we'd get 2 to the 4th, a to the -12th, right? So then over here, then we would have 2a to the 3rd. By the way, 2 to the 4th, excuse me. 2 times 2 times 2 times 2 is 16, right? So this is going to be 2 times 16, which is going to be 32. And then a to the 3rd times a to the -12th would be a to the -9th, right? But since we're not allowed to write our answers with negative exponents, we're going to get 32 over a to the +9. All right. And one last thing, and then we're done. When you have problems like this, I just want to remind you, a negative exponent on the bottom is a positive exponent on the top and vice versa. So what I often recommend students do is first just eliminate the negatives. So 3 is the coefficient. I'm going to leave that. 2 is the coefficient. I'm going to leave that. X to the positive first, I'm simply going to leave that. But that y to the negative 2, I'm going to move it down to the bottom and make it y to the positive 2. And y to the negative 3, I'm going to move to the top and make y to the positive 3. You don't have to do that. I think it just makes your life a little easier. So in this case, I could write m and n and m squared. They're not going to change, but that n to the negative 3, I'm going to move down to the bottom and make it n to the positive 3. So then I'd have this down here that I could simplify. All right, well, I know this can be a little bit complicated. You may need to watch this video more than once or pause it as you're working through problems. Find one similar that I did. I hope this was helpful, like I said, but if not, you can always ask for more help. All right, have a great day, everybody. See you next time.